A very good morning to one and all. It gives me immense pleasure to welcome you all for the one-day national webinar on fuzzy sets and its applications, organized by the Department of Mathematics, Little Flower Degree College, Uppal, Hyderabad. This is Prashant, Head Department of Mathematics, is your host for today's session. Without mathematics, there is nothing you can do. Everything around you is mathematics. Everything around you is numbers. The famous quote by Shakuntala Devi. I take this opportunity to welcome our principal, Reverend Brother Vincent Reddy, our vice principal, Mrs. Jayanti Reddy, esteemed staff, participants from different institutions from all over India, and my dear students. Math can help you thrive during the COVID-19 pandemic. The great scientist Isaac Newton practiced social distancing during the plague that hit in London in 1665. He was not expected to transmission from face-to-face work with scientist colleagues. He concentrated on developing early calculus ideas with no exposure to 24/7 news cycles of escalating crisis. He developed theory of optics. So we will also inspire from this and focus on our work by maintaining social distance. Now I would like to introduce our college to you, Little Flower Degree College, located at Uppal in Hyderabad, Telangana State, a Catholic minority institution established by Montfort Brothers of St. Gabriel's. It was started in 2008 as a part of Little Flower Junior College, Hyderabad. Now I request our technical team, Mr. Raman and Vijay, to take a virtual tour of our college.
Little Flower Degree College, Uppal, Hyderabad, a Montfortian institute run by the Brothers of St. Gabriel Educational Society, has been illuminating the world around with its motto, Lead to Illuminate. In its 12 years journey of excellence, LFDC has been fostering the young generation to be humane and preparing them to compete, realizing their dreams and purpose in life on the competitive global platform.
good educational environments,
discipline,
practical skills,
helped me in getting my first job,
excellent placement opportunities.
LFDC is an awesome college.
Dear parents and students, Little Flower Degree College, Uppal, Hyderabad has begun its admissions for the academic year 2020 and 21. The online application for the 3-year degree in BA, BSc, BCom and BBA is now available on our website.
Little Flower College,
LFDC,
Little Flower Degree College.
Thank you, sir. Now I request my colleague, Mrs. Swapna, to introduce our eminent speaker of the day, Dr. L. Sujata Madam Garu. Over to Swapna, ma'am.
Good morning. Sir, able to hear me?
Yeah.
Good morning. It's my immense pleasure to introduce today's speaker, Dr. L. Sujata. Dr. Sujata did her MPhil from Madurai Kamaraj University and obtained her doctorate from Tiruvallur University in March 2017. Her area of specialization is fuzzy set theory and its applications. She guided 18 MPhil students till date and has a which include Dean of Sciences, Chief Examiner for UG, PG, and MPhil. She is a life member of many organizations such as ResearchGate, INAAR, Association of Academicians and Research, American Society of Research, etc. She is a member of editorial board and reviewer for students. She is a chairperson and resource person at various conferences held nationally and internationally. She has presented 31 articles. Ahmedabad. She also won Best Professor Award from Puducherry Academic Research Association on Jan 4, 2020. Currently, she is an assistant professor and head of PG and Research Department of Mathematics, Auxilium College, Vellore. Little Flower welcomes you, ma'am, to this webinar. Or to Prashant, sir.
Thank you, madam, for introducing our eminent speaker, Dr. L. Sujata, madam. A small announcement to all participants. Please post your queries in the chat box, which will be addressed at the end of the session. Once again, I'm announcing small announcement to all the participants. Please queries and questions in the chat box, which will be addressed at the end of the session. Over to Dr. Sujata, ma'am.
So good morning to all.
Good morning, madam.
Am I audible?
Yes, ma'am. You're audible, ma'am.
Okay. So thank you for the nice introduction. So let us start the session. So shall I screen share, sir?
Yes, ma'am. You can share, ma'am.
Are you able to see the screen? All
Yes,
the participants are able to see the screen?
Yes, ma'am.
Okay, sir. So already they have given a nice introduction about me. So today we are going to see a nice topic, which is nothing but fuzzy set theory and its applications. Before going to the fuzzy set, we will see what is the classical set. Classical set is nothing but a crisp set. Already know, everyone knows that it is nothing but a well-defined collection of objects. But now I am going to introduce one more concept in this. That is, it is true for everyone. For example, if I am taking B as a collection of colors in a rainbow, my answer will be Vibgya. If I am asking that same question to some other person, that some other person will also give the same answer. So the answer will be true for each and every person in the crisp set. I have given some more example also here. A is a collection of planets in a solar system. C is a collection of vowels in English alphabets. D is a collection of X such that X is nothing but a multiple of 2n, where n is a natural number. So for all this, the answer given by each and every person remains the same. Now coming to the fuzzy set, I will take the first example, which is nothing but a good player in cricket. Here, the good gives you the vagueness because it is not measurable. For me, the good player is Dhoni. For some other person, it may be Virat Kohli, and for some other person, Sachin. So here, the idea varies from person to person. So it comes under the fuzzy set. So I have given some more examples also here. Interesting books. This interesting gives you the vagueness, so it comes under fuzzy. Then next one is favorite food of teenagers, favorite flavor of ice cream. In this, the favorite gives you the vagueness. So now, crisp means whatever question you are asking, the answer will be same to each and every person. But when you are coming to the fuzzy set, the idea varies from person to person. So here we are going to differentiate the fuzzy set and the crisp set. With an example, again with an example, I will explain this. Expensive house. So here that expensive gives you the vagueness because for me 1 lakh is an expensive. For some other person 2 lakh will be an expensive. For some other person 50,000 will be an expensive. So here in the fuzzy set, you are having the vague boundary. But when you're coming to the crisp set, it's given here, house with price more than 5 lakhs is considered as an expensive house. So here you can see the sharp boundary. That is, a price more than 5 lakhs is considered as an expensive house. Okay, so this fuzzy set is nothing but the generalization of the crisp set. Here, example, you can see tall men. Here, tall gives you the vagueness because it is not measurable. So now come to the fuzzy set, you can see that there is a sharp boundary. They are saying that men with height greater than or equal to 6 feet. And come to the next example, small circle. Here, small gives you the vagueness. Now come to the crisp set. Circle of radius less than or equal to 2 is considered as a small circle. So the one thing you have to remember here, in the fuzzy set, you will have a vague boundary, but in a crisp set, you will have a short boundary. So now you will move to the characteristic function of a crisp set. It is nothing but a mapping from the universal set to the set 0, 1. That is, if an element belongs to the set, it takes a value 1. And if it does not belongs to the set, it will take the value 0. So here we are following yes or no type. That is, yes means 1, no means 0. Or I can also say it in this form, true or false. True means 1 and false means 0. So you can see that in the figure, A and B are inside the set. So the membership function, not the membership, characteristic function of that is 1. And C and D are outside the set. So the characteristic function of that is taken as 0. The scientists argued that human thinking does not always follow yes or no logic. Because of this only, the fuzzy set theory was developed. So before going to the membership function of the fuzzy set, with an example, I want to explain this. So here X is a universal set and A is a fuzzy set. You can see that the small a is an element of a set A and it is inside the set. So it takes the membership function as 1. Now you can see that another element B in the universal set, but it is not inside the set A. So I am going to give the membership function as 0. So now you can see the element C. It is not inside the fuzzy set A and it is also not so far away as B. So I don't want to neglect this concept. So I am going to give some membership function in between 1 and 0. So that is 0.5. Now coming to this another element D. This D is not as close as C to the set, and it is not as far away as B. So I want to give the membership function in such a way that it must be less than that 0.5 and it must lies between 0 and 1. So you can see here 0.25 because it is not that much close to that set A. So now you come to that membership function of a fuzzy set. The membership function of a fuzzy set is a mapping from the universal set to the closed 0, 1. So you must remember in a crisp set is a mapping from the universal set to the set 0, 1. But here it is a mapping from the universal set to the closed interval 0, 1, where 0, 1 are included and in between points are also included. So how to write this fuzzy set? Here I think it's clear to you. How to write that fuzzy set? It is nothing but you have to mention the element of a universal set and its corresponding membership function. So here I have written that fuzzy set. The elements in the universal set are A, B, C, and D. So you see that A, for an element A, the membership function is 1.0. For an element B, the membership function is 0.0. And for C, it is 0.5. And for D, it is 0.25. So coming to that, and here in this slide, I have mentioned A tilde. Because I want to differentiate fuzzy set from the crisp set. So the definition is given in the form of an A tilde, but throughout I am going to use only E. Now coming to that, we will differentiate what is fuzzy set and what is crisp set. So in the crisp set, we are going to employ bi-valued logic. That is, if I'm asking, is Nick honest? If the answer from the person is yes or no, then it will take 1 or 0. So it comes under bi-valued logic. But when you're coming to the fuzzy logic, is Nick honest? If someone gives the answer as extremely honest, I'm going to give the membership function as 1. And if someone gives extremely dishonest, I'm going to give the membership function as 0. But there will be some person who can judge like this. Nick is very honest. So that very honest is somewhat closer to extremely honest. So I'm going to give the membership function as 0.85. But some may judge like this, sometimes honest. So I'm reducing the membership function as a 0.35. So in the crisp, you can see that we are following the Boolean logic, yes or no, 1 and 0 alone. But when you're coming to that fuzzy logic, you can see clearly that you're considering 0 and 1 and also the in-between values. So this fuzzy set employs infinite valued logic. So now coming to the types of uncertainty. There are two types of uncertainty we will come across. One is random uncertainty and another one is non-random uncertainty. So the probability theory falls under random uncertainty and the fuzzy set theory falls under non-random uncertainty. What is this random uncertainty? Here, the occurrence of events is strictly determined by chance. So everyone knows this example. If I want to get a probability of getting a head and a tail while tossing 2 coins at a time means surely it is nothing but the favorable cases by the total number of cases. So the favorable cases are 2. Favorable cases are 2 here and the total number of cases is 4. So 2 by 4 we will be getting it as 0.5. So now coming to that non-random uncertainty. The first one is the information which is not fully reliable. If I am asking one person, how many members are there in your family? If that person gives me the answer 5, it's okay, well and good.
Ma'am,
But
sorry to interrupt you, ma'am.
yeah,
A little bit slow. Can you go now, ma'am? Some participants are asking. Sorry to
oh,
interrupt you. Okay, ma'am.
okay,
Right,
okay,
right,
okay,
right,
okay.
ma'am.
So you want
Thank
me
you.
to repeat any point, sir?
No, ma'am. Just a little bit. Last slide.
Ah, okay.
Yeah.
This one. Okay. So there are two types of uncertainties we can see. One is random uncertainty and another one is non-random uncertainty. So the probability theory falls under random uncertainty and the fuzzy set theory falls under non-random uncertainty. What is this probability? So here the occurrence of events is strictly determined by chance. For example, the probability of getting a head and a tail in tossing two coins at a time means we know that it is nothing but the favorable number of cases divided by the total number of cases. Here the favorable cases of getting a head and a tail is nothing but here this one and this one are the favorable cases. So 2, but total number of cases is 4 for me. So 2 by 4. So you are getting it as 0.5. So now coming to the non-random uncertainty. The first point is information which is not fully reliable. So if I am asking someone how many members are there in your family, and if that person is able to give the answer as a 5, it's okay, well and good. If not, if he says that I think so, 5 members. So I think so, there itself the vagueness is created. Okay, so he is not able to accept his own answer. So I am saying that the information which is not fully reliable comes under non-random uncertainty. Next one is receipt of information from more than one source about the problem which is conflicting. So I am standing in a bus stand. I am asking one person when the Chennai bus will arrive. That person is giving me the answer as 15 minutes. And I am approaching another person and I am asking the same question. And that person is giving me the answer as 10 minutes. And I am moving to some other person. Again, I am posing the same question and that person is giving me the answer as 20 minutes. So you can see that the receipt of information from more than one source about the same problem, but which is conflicting. So all this comes under non-random uncertainty. Next one is imprecision in the language with which the problem is expressed. Imprecision, that means I'm asking one person, what's the distance from Auxilium College to Katpadi railway station? As an example, I'm taking this. So if a person gives answers 5 kilometers, it's well and good, it will be in the crisp set. But if the person gives about 5 kilometers, around 5 kilometers, if we introduce that about and around, which gives the imprecision in the language, which is also called as linguistic language. So now from this figure, it is clear that certainty occupies only a few space here, and random uncertainty is somewhat more than that certainty, but majority of the place was occupied by non-random uncertainty. So we can clearly say that fuzzy set theory plays a vital role in day-to-day life. So now we will see the standard fuzzy operations. Everyone knows the union operation, intersection operation, and complement operation in a normal crisp set. Now we are going to deal that with the fuzzy set. Here I have taken two fuzzy set. One is A and another one is B. So you can see that the element from the universal set, it is associated with its membership function. Here element from the universal set associated with its membership function. So now we are going to find the union of these two, which is nothing but the elements from the universal set associated with the membership function. But the membership function, how it is defined, you can see it is nothing but the maximum of the membership function of A and the membership function of B. Now I will explain this using the example. So I have taken X as a universal set, which runs from 1, 2, 3, etc. 10. Here, that 1, 2, 3 stands for the bedroom. That is 1 bedroom, 2 bedrooms, 3 bedrooms, etc. till 10 bedrooms. Now, first, I am going to frame the fuzzy set A tilde. So, what is this A tilde? It is nothing but a comfortable house for 4 persons. So, I am going to judge the comfortable house based on the bedrooms. Okay, first I will frame the fuzzy set A tilde, then we can move to the fuzzy set B tilde. Is okay. So I told you that for framing the fuzzy set, how you are going to frame means element in the universal set and its membership function. So now coming here, so this first elements 1, 2, 3, 4, 5, 6, everything are the elements from the universal set. But I have neglected 7, 8, 9, 10. But I will tell you why I have neglected that. Okay, so this 1, 2, 3, 4, 5, 6, everything are the elements from the universal set. Now I am going to give the suitable membership function for that elements. So if I am having 4 persons, which will be the comfortable house? So I must have 4 bedrooms. Then only it will be a comfortable house. So here, this one is a 4 bedroom house. So that will be more comfortable. So I'm giving the maximum membership function as 1. Next, when you're coming to this 5, it's okay. Extra 1 bedroom, it's okay, acceptable. So but I cannot give it as 1. So I'm giving it as 0.7. Then when you're coming to the next one, 6, it's not needed that much because we are having only 4 persons. So we are not going to utilize the rest of the bedrooms. So I'm going to reduce the membership function as 0.2. And when you're coming to 7, it's not at all needed. So I'm going to give the membership function as 0. So I have neglected here. Then 8 also it will be 0. And for 9, it will be 0. And for 10 also, it will be 0. Okay, so now come to this side. So 3 means, okay, but 1 person has to adjust with 1 person. So I'm giving the membership function as 0.8. 2 means it's somewhat difficult only. So I have reduced the membership function as 0.5. 1 means surely it will be somewhat difficult. So I have reduced. So which is the comfortable one here is a 4 bedroom. So you can see it reaches the maximum membership function here. That when it is 5, 6, 7, 10, the membership functions automatically reduces. And when you're coming this side also, the membership function automatically reduces. So thus we have framed the fuzzy set A tilde. Now come to the another fuzzy set B tilde. The fuzzy set here is small house. So what is this small house? So according to the human thinking, if it is 1 bedroom house, then that will be the small house. So here you can see that I told you already the first one stands for the universal set elements, which denotes the bedrooms. So the next one is nothing but the membership function, what I am going to give. Okay, according to the fuzzy set, how it is described. Yes, so 1 bedroom. So surely it will be a small house. So I'm giving the maximum membership function as 1. So when it is 2 bedrooms, it's okay, I can consider, but I am reducing it as 0.8. But when it is 3, surely it will not be considered as a small house, but somewhat. So I'm giving the membership function as 0.4. So it goes on like that. But when it is 5, 6, 7, 8, 9, 10, it cannot be considered as a small house. So the membership function of it is taken as 0. So I have not introduced here. So now we have framed 2 fuzzy sets. And from here, we are going to get the union of these 2 sets. So as I said, so first you have to write all the universal set elements. So 1 to 10, if you want, you can include that 1 to 10 also. But I have written only till 6. You can also write till 10. So now I'm going to find the maximum of these 2 membership functions, that is 0.1 and 1. And the maximum value is 1 for me. So I am writing here 1. Then for this 2 bedroom, the maximum of the membership function 0.5 and 0.8 is 0.8. So I am writing here 0.8. Similarly, you can continue with the rest of the elements. In this way, you can find the union of the fuzzy sets. Coming to the intersection of a fuzzy set, here we are going to follow the same condition, that is, you are going to take the element from the universal set and you are going to attach the membership function. But here the membership function is taken in such a way that it is minimum of the membership function of A and the membership function of B. So in union, you must be clear that it is maximum of the membership function, and in the union, sorry, in the intersection, it is a minimum of the membership function. So I have taken the same example, so I don't want to give a much more explanation for this, but directly we can go for the intersection part. So we are writing all the elements from the universal set. So 1 for that 1 bedroom, minimum of this is 0.1. For the 2 bedrooms, the minimum of 0.5 and 0.8 is 0.5. Like that we can proceed. And here you are having a, for a 5 bedroom, it is 0.7. And as I said here, I have not mentioned 5 bedroom in the B tilde, but it is understood it is 0. So the minimum of these two, that is 0.7 and 0 is 0. So I have written here. So I think this concept will be clear to you. Now coming to the complement of a fuzzy set. So this is my fuzzy set A. So how to find the complement? You are writing the universal set element. Along with that, you are attaching the membership function. The membership function is formed in such a way that it is nothing but 1 minus of the membership function of A. So here already you know this fuzzy set A tilde. Now I am going to form the complement of the fuzzy set A. So 1, I have written here 1. What is the complement here? 1 minus of 0.1, which is nothing but 0.9. So here 2 I have written. What is the complement of this 0.5? 1 minus of 0.5, 0.5. So like that you can proceed and you will be able to arrive this point. And what is the membership function here? It is in the A tilde for 7 bedroom. It is 0. So now come to the complement. What happens here? 1 minus of 0. So you are getting the answer as 1. So like that you can proceed till 10 bedrooms. Okay, so this A tilde is nothing but a comfortable house for 4 persons. So its complement is nothing but a non-comfortable house for the 4 persons. So these are the standard fuzzy operations, 3 operations which you have to remember. Okay, now you know that there are features of crisp set. Many features of crisp set are given. De Morgan's law, everything will be coming under the features of crisp set. And the fuzzy set will satisfy all the features except the 2 features. One is law of contradiction and another one is law of excluded middle. What is this law of contradiction? In a crisp set, you'll be able to say that a set and its intersection of its complement will be equal to 5. But this will not be satisfied in the fuzzy set. Next, law of excluded middle. A set and union of its complement will give you the whole universal set in a crisp set, but this is not satisfied in the fuzzy set. Now coming to the fuzzy sets can be discrete or continuous. So you know what is discrete. So we will be able to count it in a finite number of time, that is finite amount of time. Continuous means it will take a lot of time for you to count. So now you're coming to this equation 1 that denotes the discrete type of fuzzy set. And this equation 2 denotes the continuous type of fuzzy set. Here I have used for the discrete summation and for this continuous type I have used integration, but we are not going to sum up or we are not going to integrate. It's only the notation we are giving to differentiate discrete variables and the continuous variables. Now coming to that alpha cut. So all these are basic things which everyone must know about the fuzzy set. So what is this alpha cut? So that alpha cut is nothing but the collection of the elements taken from the universal set so that the condition must be satisfied. So what is that condition? It is nothing but the membership function of that must be greater than or equal to alpha. So first you have to check the condition, then the element of the universal set which satisfies this condition can be put in this alpha cut set. So I have given one example also. Here is a small example. So I have taken X as a universal set 1, 2, 3, and I have formed the fuzzy set here. So that is, I have connected some membership function related to the fuzzy set as an example. And I told you that in the previous slide, if it is of discrete type, it can be written as the membership function, the element and the membership function, element and the membership function, element and the membership function. So I am using the same here, element 1 and the membership function 0.3, element 2 membership function 0.5, and element 3 membership function 1. So this fuzzy set can also be written in this form when it is a discrete type. Now come to this part. I'm going to get the alpha cut for 0.5, alpha cut set for 0.5. Yes, so 0.5 means first we have to check whether the membership function is greater than or equal to 0.5. Here 0.3 is not greater than or equal to 0.5. Here 0.5 is okay, it's equal to 0.5, and next one it is 1, which is greater than 0.5. So what is acceptable here means the element which satisfies that condition. So which is nothing but 2 and 3. So I have written here. Now coming to this alpha cut set which takes the value 0.1. So here 0.3 is greater than 0.1. 0.5 is greater than 0.1 and 1 is also greater than 0.1. So I am writing all the elements. So now coming to alpha cut for 1. So if I am taking that alpha cut for 1, here 0.3 is not greater than 1, 0.5 is not greater than 1, but 1 is equal to 1. So I am taking only one element here. So here we are getting a nice result that if I am taking the alpha cut set 0.1, 0.5 and 1, you can say that 0.1 less than 0.5, which is less than 1. But when you are comparing this set, you will be getting the reverse process. You can say that this alpha cut set with respect to 1 is contained in alpha cut set with respect to 0.5. And that is in turn contained in alpha cut set with respect to 0.1. So now coming to the continuous time. I'm taking the membership function as real number near A. This is the constant membership function. So it is nothing but 1 by 1 plus x minus A the whole square. The next membership function, what I'm going to take here is a real number very near A. So the formula for this is 1 by 1 plus x minus A the whole square, the whole square. So now in my example, I'm going to use a real number near 0. So what will be the formula? It is nothing but 1 by 1 plus x square. And also I am going to use another example, which is nothing but a real number very near 0. So my answer, that is the formula will be in the form of 1 by 1 plus x square, the whole square. Coming to this figure, all the universal set lies along the x-axis and you will be having the membership function along the y-axis. So here already I told you this is the membership function for a real number near 0. I want to find out the membership function for 0 itself. So if I am substituting x as 0, I'll be getting the membership function as 1. So for 0, the membership function is 1. Now coming to 1, it is also somewhat near to 0. So when I am substituting here 1, so what happens? I am getting 1 by 2, which is nothing but 0.5. So for this, the membership function is 0.5. And even if I am taking minus 1, there is no problem. I'll be getting the same 1 by 2 only. So I'll be getting the membership function as 0.5. So you see that When it is very closer, if we are taking it as x as 0.5, the membership function of that will be more. Why? Because it is near to 0. Now coming to that next example here, a real number very near to 0. So this is the formula. Yes, okay. Coming to this, if I am substituting 0 here, I'll be getting what? 1 as a membership function. So for 0, the membership function is 1. And for 1, what happens? Here, if you are substituting 1 here, then you'll be getting the answer as 0.25. And for -1 also, you'll be getting the same 0.25. So from this statement, you can see that the same universal set I am referring here in this slide, and the same I am referring here, but in the previous one, the membership function is 0.5, but here the membership function is 0.25. So you can come to the conclusion that whatever elements you are taking in the universal set, the membership value differs based on the fuzzy set what you are creating. That one is a real number near 0. The previous one is a real number near 0. Is a fuzzy set, and now it is a real number very near to 0. So in this, if you are taking x as 0.00001 like that, if you are taking means surely that is very near to 0. So that membership function of it will be surely increase. So all this comes under continuous because I can continue with the numbers. Now coming to the fuzzy number. This fuzzy number is nothing but a special type of fuzzy set. So you know that the fuzzy set is defined in the form of mapping from the universal set to the closed 0,1. But here the fuzzy number, which is a special type of fuzzy set, is a mapping from the real line to the closed 0,1. So it is nothing but a generalization of a regular real number. That is, if I am taking a crisp number, means it is a single valued number. But when you are coming to the fuzzy number, means it will take connected set of possible numbers. For example, if I am asking the time taken to travel from one particular place, that is from Auxilium College to Katpadi railway station, like that, if I am asking, means if a person gives me 20 minutes, so it is a single valued number. So it comes under crisp. But I told you, if that person gives me the answer as about 20 minutes, so it can be 15 minutes or it can also reach 25 minutes. So now you see that I am giving the connected set of possible values, which is 15 minutes, 20 minutes, and 25 minutes. So I can say that this fuzzy number is nothing but a generalization of a regular real number. So I have given this. So it does not refer to one single value, but it refers to a connected set of possible values. So there are two famous fuzzy numbers. I can say that it's a famous itself. So why? Because one is a triangular fuzzy number and another one is trapezoidal fuzzy number, because it is used in many applications. Yes. So now coming to the triangular fuzzy number, it is denoted in the form of a triplet, that is A1, A2, A3. And see, this condition is very, very important, that A1, A2, A3 must be an element in a real line, and with the condition A1 less than A2 less than A3. This condition must also be satisfied. So this is the example of a triangular fuzzy number. But I have taken this A1, A2, A3 in the positive side. So I can also mention it as R plus. Okay, so now coming to that, when you will use this triangular fuzzy number, already I told you that if I am giving the answer as around about 5 minutes like that, I can, if I am saying means I can make use of this type of triangular fuzzy number 4, 5, and 7. Okay, yes. So here you see that this 4, 5, and 7 will lie in the real line, and here also you can see that 4 is less than 5, 5 is less than 7. The condition is satisfied. Now we are going to give the membership function for this triangular fuzzy number. So the membership function is defined like this. So along x-axis, this is my x-axis. If a number x, if this number x lies between A1 and A2, then the member, sorry, then the membership function is given like this. That is x minus a1 divided by a2 minus a1. So that is given here. If the membership, that is if my x value is a2, then its membership value is 1 for me. So I have given here. When my x value lies in between a2 and a3, then the membership value is calculated like this: a3 minus x divided by a3 minus a2, which is given here. So when it is, that is, if you are considering the values less than a1, and if it is more than a3, then its membership value is treated as 0. So this is very, very important concept of triangular fuzzy number framing the membership function. Coming to this example, here I have taken the triangular fuzzy number as an example 1, 5 and 10. So you can see that 1, 5, 10 belongs to our 1 less than 5 less than 10 also. Yes. So now coming to this part is so the 3 lies between 0, sorry, not 1 and 5. Okay, how to calculate? I have calculated the membership function as 0.5. How it is possible? Already I told you. So for this one, the membership function, how it is calculated, you can take this 3 as x. So how to do? X minus 1 divided by 5 minus 1. So in the place of x, if you are substituting 3 means what you will get? 3 minus 1 divided by 5 minus 1. So that you will be getting the membership function as 0.5. So now coming to this part, 6 lies between 5 and 10. So how to calculate? I am going to take this as x. So how to calculate according to the membership function? It is 10 minus x divided by 10 minus 5. So here x takes a value 6. So 10 minus 6 divided by 10 minus 5. So that you will be able to get this membership function. Okay. Yes, sir. Now, if you know the value of x, you are able to calculate the membership function. But now we are going to see the reverse part of it. If I know the membership function, is it possible for me to calculate the values of x? Surely it's possible. So now I want to calculate the value of this element here. So I don't know what is that element, but I know that its membership function is 0.5. So what can I do? First, I have to check where this number lies, the right side or in the left side. Now it lies in the right side, that is in between 5 and 10. So you know that formula for that. So how to calculate? I'm going to take this part as x. So 10 minus x divided by 10 minus 5, that is equal to the membership function. So the membership function here, it is nothing but 0.5. So you can substitute and you can get the value for x. So now you come to this point. If this maximum height is 1, then the fuzzy set is said to be normal. If the maximum height is less than 1, then the fuzzy set is said to be subnormal. According to our example, the maximum height is 1. So I am taking this fuzzy set as normal fuzzy set. If not, it becomes subnormal. Next, come to the definition of a crossover. What is this crossover? It is nothing but the collection of element of x for which the membership function must take only 0.5. That is in between value of 0 and 1. So according to our example, I'll be taking here 3 because the membership function for 3 is 0.5. Even if you want, you can get the value and that value can be pasted here. Coming to the alpha cut interval for triangular fuzzy number. This is also very important concept used when we want to convert the triangular fuzzy numbers to an interval number. This formula can be utilized. But how to get that formula? You see that this interval, that L alpha and AR alpha is called as the alpha cut interval. Okay, so here the membership function is nothing but alpha for me. Yes, already I told you how to calculate this AL alpha and AR alpha. That means first you have to verify where that AL alpha lies. It lies between A1 and A2. So how to do that? Can write it in the form of AL alpha minus A1 divided by A2 minus A1. And that is equal to the membership function, which is nothing but alpha. So from this, you'll be able to calculate what is AL alpha. Coming to this side, how to calculate the membership function? A3 minus AR alpha divided by A3 minus A2. That is equal to the membership function, which is nothing but alpha. And from there, you can calculate AR alpha. This is very, very important. If when you want to convert the triangular fuzzy number in terms of interval number while solving some of the problems. So now coming to that addition, subtraction operations in a triangular fuzzy number. A and B are the two triangular fuzzy numbers I have taken. The addition operation is very simple. That is, we are going to add the first element with the first, second element with the second, and the third element with the third one. Now coming to the subtraction operation. Here, we are not going to subtract A1 minus B1, A2 minus B2, A3 minus B3. Why? Because if we follow that type of rule, then an important condition of triangular fuzzy number will be violated in some places. That means A1 less than A2. If I'm taking the triangular fuzzy number as A1, A2, A3 means the condition must be, it must be in a real line, and also A1 less than A2 less than A3 condition must be satisfied. So that will not be satisfied. So for that only we are introducing the new subtraction operation in the triangular fuzzy number. That is this first element minus the last element. Next, second element with respect minus the second element, and the third element minus the first element. So this is the subtraction operation we are going to follow, so that surely the first element A1 minus B3 will be less than A2 minus B2, which is less than A3 minus B1. Now come to the symmetric image. I know what is my A, which is nothing but A1, A2 and A3. So with the condition A1 less than A2 less than A3. Now you are coming to this minus A means, you see that I have to insert minus here. I cannot write it in the form of minus A1, minus A2, minus A3. For example, if I am taking A as 1, 2, 3, 1 less than 2 less than 3 is okay. If I want to put minus sign there, if I'll be getting that minus 1, minus 2, minus 3. If I'm writing means, you see that whether that condition is satisfied or not. Minus 1, is it less than minus 2? And minus 2, is it less than minus 3? The condition is violated there. So what to do for this? You have to mention minus A as minus A3, minus A2 and minus A1. Coming to this one. So I have taken two triangular fuzzy number A and B. So you see that first one is minus 3, 2, 4, minus 3, and 2 here I am having 2, and here it is 4. Then B is minus 1, 0 and 6. Okay, now I am going to add these two elements. So if I am adding these two elements, I am getting it as minus 3, minus 1, will be getting minus 4, 2, minus 0, then 4, minus 6, sorry, not minus, minus 3, minus 1, minus 4, you are getting 2 plus 0 and 4 plus 6. So we'll be getting this 10. So now coming to this subtraction operation, we'll be doing this like this: minus 3, minus 6. So we'll be getting it as minus 9, 2 minus 0. So we'll be getting it as 2, and 4 minus of minus 1. So that you'll be getting it as 5. So that I have denoted it in the form of a figure. Now, the very big problematic operation is the subtraction operation. So if I am taking 1, 2, 3 as one fuzzy number, another fuzzy number, the same one, 1, 2, 3, you have to get the value as 0, 0, 0. But I told you that direct subtraction is not at all possible in some cases. So what we'll do, first element with the last, second with second, and third with third. So when you are doing like that, you will be getting the answer as minus 2, 0, 2, which is not equal to 0, 0, 0. So for that, what many researchers, what they will do, no, they will apply this ranking methods. For example, one small ranking method I can say, it is nothing but the arithmetic operations if you are doing, but it is not best one, but I am saying that it's a small one which you can utilize here for this example. So minus 2 plus 0 plus 2 divided by 3, if I am taking, means it is converted to 0. So through ranking function, they are converting it to 0. Now coming to the trapezoidal fuzzy number, the triangular you are having three triplets, and here you will be getting A1, A2, A3 and A4. The same condition I am going to follow here. All the 4 elements must be in the real line and with the condition A1 less than A2 less than A3 less than A4. So when you can use this trapezoidal fuzzy number, if I am denoting middle age, so middle age means then 35 to 45 can be considered as a middle age. So it will take the membership function as 1. So after that, that is the membership function reduces because it cannot be considered as a middle age here. So 35 to 25, the membership function will be reduced, and similarly 45 to 50, the membership function reduces. So this is an important type of fuzzy number. Yes, and when A2 is equal to A3, what happens? The trapezoidal fuzzy number is converted to a triangular fuzzy number. So here you can see the membership function here. What we have followed for the triangle, the same thing I am going to do here. If x value lies here in between A1 and A2, then x minus A1 by A2 minus A1. When x value lies here, then A4 minus x divided by A4 minus A3. And when x value lies in between A2 and A3, the membership value is 1. And when you are taking the x value which is less than this A1 and greater than this A4, then it will take the membership function as 0. So now we are going to see some important definitions. Here, support, core and boundary. What is this support? It is nothing but the collection of elements in X for which the membership function must be strictly greater than 0. So you can see here when the membership function will be 0, when it is go outside this range, this will be 0 and this will also be 0 form. So here the membership function will not be 0. So this is my support. Coming to the core. So you must have that you are going to take the element from the universal set for which the membership function is equal to 1. So where you will have the membership function as 1, only in this range you will have the membership function as 1. So that particular element, that X elements you can put in this core. This boundary of it. What is this boundary of it? It is a collection of elements from the universal set with a condition. What is the condition to be satisfied? Membership function must lie between 0 and 1. So here you can see that here it is 0 to 1, it's a boundary, and here also it is 0 to 1, it's a boundary for me. Now, already I told you how to create an alpha cut interval for triangular fuzzy number. The same thing will be followed here to get the alpha cut interval for trapezoidal fuzzy number. And this will also be very, very useful if you want to convert the trapezoidal fuzzy number in terms of an interval. And you can also apply this in many problems like shortest path problem, longest path problem, and many problems, optimization problems. Now coming to this extension of a fuzzy set, which is nothing but intuitionistic fuzzy set. So this intuitionistic fuzzy set was first introduced by Atanasov. So what is this intuitionistic fuzzy set? So usually in the fuzzy set, we have seen that you will have an element from the universal set and the associated membership function. But here I am going to introduce the non-membership function for it also. So that this is called as an intuitionistic fuzzy set. And here the membership function will also range from the universal set to the close 0, 1. Non-membership function also range from the universal set to the close 0, 1. With the condition that the membership function, the sum of the membership function and non-membership function must lies between 0 and 1. The condition must not be violated. Now, the special fuzzy set, which is nothing but the triangular intuitionistic fuzzy set we are going to refer. Yes, so already you know about this membership function. We are going to deal with the non-membership function here. So here you see that how they have defined the triangular intuitionistic fuzzy number A1, A2, A3, A1 dash, A2 and A3 dash. So I want to compare all these numbers. How you see that comparison is given like this. A1 dash is less than A1, which is less than A2, less than A3, which is less than A3 dash. Where all that elements must be in R. So this is the important condition what you have to remember. Now coming to this membership function, already you know based on A1 A2 and A3. We have framed this. Then how to frame this non-membership function? It is based on this complement part. Yes, sir. So here, if you are clear with this membership function, easily you can frame this one. So now you come to this one. From A1 to A2, the membership function increases. So from A1 to A2, the membership function increases. So I am using this type of membership function, which is nothing but x minus A1 by A2 minus A1. So here from A2 to A3, the membership function decreases. So here I am using the concept that A3 minus x by A3 minus A2. So similarly, I am going to apply here. So from A1 dash to A2, the membership function decreases. So here it decreases, and the same way here also the membership function decreases. So what I am using here, I have to use for this also, that is A1 dash less than x less than or equal to x less than or equal to A2. So here having this as in the form of what is that? What you have used here? What you have used here? A3 minus x by A3 minus A2. So here how to use A2 minus x divided by A2 minus A1 dash. Because for this and this, the membership function is reduced. Now coming to this one, yes, coming to this part, that is when you are saying that if an element lies between A1 and A2, what happens? The membership function increases. And when you are coming to this part, A2 to A3 dash, the membership function increases automatically. So what is this membership function? When it increases, you are using x minus A1 by A2 minus A1. So here also, when it is from A2 to A3 dash, the membership function increases. So this concept I am going to use here. So what you will get here, x minus A2 divided by A3 dash minus A2. So you are able to frame the membership function. The next final one. So for this one, A1, A2, A3, A2 reaches the maximum membership function 1. So you have written here. Now come to this part. Here for A2, the membership function is 0. So I am writing here. Then for this one, when you are moving away from A1 or A3, that is A1 and A3, the membership function takes 0. And when you come here, you see that when I am moving away from this A1 dash and when I am moving away from this A3 dash, the membership function takes the value 1. So you have written here. So in this way, you have framed the membership function for triangular intuitionistic fuzzy number. The same thing can be followed for trapezoidal intuitionistic fuzzy number. So next, coming to the ranking of fuzzy number. It is an important issue in the study of fuzzy set theory. Because if I am having a single number, 5 and 8, I will be able to compare easily. But some fuzzy numbers are not comparable easily. So for that, what we have to do means we have to defuzzify the fuzzy number for the sake of comparison. So now, if I am having three numbers, that is two numbers, 3, 5, 8, and 2, 4, 9, or two triangular fuzzy numbers, I don't know how to compare these two numbers. So what we can do, we can make use of some of the ranking functions, and from there you can judge that which is greater and which is smaller. Okay, so that ranking function is called as the defuzzification of fuzzy numbers, which is nothing but the fuzzy number converted to a crisp number. So next, what is this fuzzification? A single number can be converted to a fuzzy number. Okay, if I am saying about 5, then I can write it in the form of 3, 5, 8. Also, the single number is converted to a fuzzy number. So that is called as a fuzzification. So here we are going to see the application of fuzzy shortest path problem using ranking functions. So it's a very simple example, and also we have applied the algorithm for that. But here I am giving a simple concept to understand easily this fuzzy shortest path problem. So I have taken a small network. The source network is Chennai and the destination network is Tiruchirappalli. I am connecting that network and I want to find the shortest route so that minimum time or the cost must be minimum for me to travel from Chennai to Tiruchirappalli. Cost or distance or whatever you can take it. Here I have given the duration in terms of trapezoidal fuzzy number. For each and every activity, I have given the duration in the form of a trapezoidal fuzzy number. What you have to do means you have to calculate possible paths, all the possible paths from the source vertex to the destination vertex that I have given here. Then you have to sum up that activities. That means already I have given how to add the two fuzzy numbers. So that you have to make use of here. That is, you have to add what is that 1 to 2, what is that activity that must be added to 2 to 3, 3 to 5, then 5 to 6. So that you will be getting this L1 tilde. Like that you have to do for all the possible paths. Then you have to find. Next, coming to the L minimum. How to calculate this L minimum? It is nothing but the minimum of the first element. So the minimum here it is 159. I am writing here. Then here the minimum of this element. So which is nothing but 195. Like that you are going to calculate L minimum. Yes. Now I am going to compare L minimum with this L1, L minimum with L2, L minimum with L3 and L4 and L5. So now we have given the similarity degree for that. If there is no intersection between L min and Li, then the similar, if there is no intersection at all, then it takes a value 0. If there is an intersection and the intersection is in the form of a triangle, if it is in the form of a triangle, then the similarity degree is defined in this form. I don't want to go in depth how we are creating that similarity degree. The formula alone I have given here. Yes. If the intersection area between L min and Li is in the form of a trapezium, then we have given the similarity degree here. So this will be useful for us to find the shortest path. Now come to this. So for all the possible paths, I told you that already we are having this L min and Li, and we are going to check whether that there is intersection or not. And if there is an intersection, we are going to check whether it is in the form of a triangle or in the form of a trapezium. So based on that, you are going to apply in the formula and you'll be getting this results. And the path having the maximum similarity degree is identified as the fuzzy shortest path. So from here I can say that 1, 2, 4, 6 is the fuzzy shortest path. So here what I have done means the fuzzy number which is given in the form of a trapezoidal fuzzy numbers are converted to a single number, this one. That means I have defuzzified the fuzzy number so that I'll be able to identify, because already I told you that fuzzy numbers cannot be compared as it is. So it must be defuzzified to be compared. So like that we have defuzzified and we have done this. Now coming to the transportation problem. So the main problem is what we have done. If you are defuzzifying means the fuzzy number is converted to the crisp number. So what many researchers, what they feel, no? So the fuzziness is violated. So without defuzzifying, is it possible for us to do this? We can use that crisp method, but without defuzzification, we have to get the result. So the final result must be a fuzzy number to me. Yes, so this is one of the shortcomings. Yes, another one is when you are going for the subtraction operation, I'll be getting this minus sign. Usually you'll be taking in the transportation assignment problem the cost values, and if you are subtracting and if the cost values are in the form of negative values, then there is no use, there is no meaning at all. The cost values are converted in terms of negative. So what we felt, without violating the fuzziness, we have to do, but we can also apply the crisp method. Yes, so already we will be aware about the different methods of solving the transportation problem. That is, first you will be going for the initial basic feasible solution. So there are different methods in initial basic feasible solution: northwest corner rule, least cost method, Vogel's approximation method, where that Vogel's approximation gives you the best approximation for the initial basic feasible solution. And you will not stop there. You have to get the optimal solution. So you will be following the MODI method, that is modified distribution method, to obtain the optimal solution. But we want to reduce that the concept. So we verified Pandian's paper, and we have formed a fuzzy transportation problem using fuzzy 0-point method, and also we have implemented that to the fuzzy 1-point method. First, if you understand the 0-point method, that 1-point method will be very, very easy. And this is also easy method to solve the transportation problem under fuzzy environment. So here I have considered the fuzzy transportation problem, where the elements are in the form of a triangular fuzzy numbers. You can see it is fully fuzzy transportation problem. So we are having 4 sources and 3 destinations. So now I don't want to violate the fuzzy condition, but I want to use the crisp condition also. So what I'm going to do means dividing this into 3 stages. That is, I am going to take the first element from each cell and I'm going to put it as a first stage. You see that this is the first stage of my transportation problem. So it has reduced to crisp now. So now I am seeing whether it is balanced or not. Yes, it is balanced. So without going to the initial basic feasible solution and the MODI method, directly we are able to get the result through this method. Yes, sir. So now you choose the minimum element in each row. So I have chosen the minimum element in each row. Next. What you have to do with this minimum element means you have to subtract this minimum element from other element in that row so that you will be able to get this. Now you check that whether each row and each column has at least 1 0. Yes, in the first row you are having second okay, third and fourth okay. Third column okay, second column okay, but in the first I am not having the 0. So now you choose the minimum element in that first column and subtract it from other element of that column, and you will get this type of table. Yes, okay. So now what I am going to do means, now I am going to start my allocation. Yes. So how to start the allocation? I am going to find only in the places of 0 I have to allocate, not in other places. So you check whether there is at least 1 0 in each row and each column. Here the 2 zeros are there, here 2, but here it is 1 and here it is 2. Yes, okay. So I will choose this one because this is the only 0 in that row, and you give the minimum of the supply and the demand. So I'll be getting here 6. So I have allocated 6. So I'll be getting here 2 and 0. So now you see that the rest of the places I am having 2 zeros in each row and each column. So I can go for trial and error method. First here I am going to choose this one, minimum of 6 and 8. So I'll be putting 6 here and it becomes 0 and here it is 2. Now here in the 0 place, here it is 2 and here already it is converted to 2. So 2 and 2 get cancelled and you'll be getting this one. Yes, sir. So now you're coming to this part. So you'll be getting 6 and 8. So the minimum is 6. So I am writing here and it becomes 2. Yes, sir. Coming to this part. Yes, I cannot allot in this place because it's already filled. Yes, I cannot allot here. It's already filled. So coming to this part is okay. Yes, sir. So minimum of the supply and the demand I am giving 6. So it becomes 2 here and here it is 0. But there is no 0 places for me to allot this 2. So my that is I have not reached the optimal solution. So what I have to do after that? I have to draw minimum number of lines covering. I have to draw minimum number of lines covering all the zeros. So I have done this here. Horizontally and vertically, you draw minimum number of lines covering all the zeros. And you see that the least uncovered element you can choose. Okay, the least uncovered element here it is 2. So you subtract the other n uncovered element using the 2, so that I'll be getting here 0 is 0 and here it is 0. And here 4 minus 2 you'll be getting it as 2. And in the intersection place you add that minimum element. So I am getting 2 here and here I am getting 4. So in the rest of the place as it is you can. Now you check whether each row and each column has at least 1 0. Yes, we are having. So now we can again go for the allocation. Yes, I already told you how to allocate. You see whether it is a single 0, then you make the allocation, and the same procedure I have followed. And now I can see that all the supplies and demands are satisfied So I have reached the optimal solution. Okay, yes. Now come to this part. You can see that the optimal solution, what I am getting is here 6. Okay, here 6. So here 8 and here 2. And in the column wise also all these are satisfied. Okay, now I will find the maximum, that is objective value for the first stage. So what you will do, what is the formula for it? It is summation of Cij into Xij. So I am taking the original table where I am having the cost matrix. So that Cij value is multiplied with Xij value, so that I am getting this 156 as the answer for the first stage. Similarly, I am going to do for the second and the third stage, and I'll be getting this fuzzy number. So the fuzziness is not violated, but I'm at the same time I'm using the crisp method, but the fuzziness is not violated here. And I can also form the membership function for this. Already you know, if it is a triangular fuzzy number, I can write it in this form. If my X value lies between 156 and 240, the membership function is here. If it is equal to 240, membership here. If lies between 240 and 340, the membership function is given here. Otherwise, it takes a value 0. So already everyone knows that Hungarian method of solving assignment problem. Now we are going to use Bazes-Zadeh's one's method, but we have given a theorem for that and we have created a new concept. But I have given a simple concept here for this one's assignment method. But everyone knows the Hungarian method. I don't want to explain this theorem, what we have given. Directly we can move to the problem. Before that, one thing alone you must remember, for one's assignment problem, if it is unbalanced, then this is the objective function. This is the objective function what you have to apply. Now coming to this fuzzy assignment problem, it is a balanced one because you are having 5 rows and 5 columns, and here it is a fully fuzzy assignment problem because I have taken it in the form of a triangular fuzzy number. And I'm going to divide this into the 3 stages. The first stage is first element in each cell I am going to take, and I have this one. Yes. So now I'm going to choose the minimum element in each row. Okay, so I have chosen this is these are the minimum elements. Usually what you will do, you will subtract that minimum element from all other elements in the row. But here what I am going to do means I am going to divide all the element by this minimum element. So if I am doing that means I am getting this. So now you check whether each row and each column has at least 1, 1. Is okay, I'm having, but in this column I'm not having. So what I have to do, again I have to choose the minimum element and divide all other element by this 1.5. So if I'm doing that, I'm getting this result. But directly I'm able to get the connection, that is C1 is related to R5, C2 to R3, C3 to R4, and C4 to 1, and C5 to C5 to this R2. So I'm able to connect it. Yes, one thing what you have to remember here is if you are not able to get this type of solution immediately, you have to draw the minimum number of lines covering all the ones. So what we did for the previous transportation problem, all the ones. Then you have to choose the uncovered element. In that you have to choose the minimum element, and you have to divide the other uncovered element using the minimum element. But and at the point of intersection, you have to multiply. So what is the difference between the Hungarian method and this one means? So there you will subtract, but here you are dividing. And at the point of intersection, you will add there, but here you are going to multiply. And one more difference here it is, there the cost can also take the value 0, but in this method, the cost cannot take the value 0, because in the row, that 0 is a minimum element. If you are dividing other element by that 0, then you will get infinity. So that is not allowed. So here one restriction you have to give, that cost must be either greater than or equal to 1. But in that Hungarian method, the cost is either greater than or equal to 0. So we have come to the conclusion here of this assignment problem. Yes, so all these assignments so C1, everything is clear here. So now I'm going to take the original table where I am having the cost elements. So what I have to do, this cost element must be multiplied with Xij. How will you choose that Xij? If there is an allocation for me in that cell means, then that will be taken as Xij and it is equal to 1 for me. So what you can do, 2 into 1 plus 1 into 1 plus 2 into 1 plus 3 into 1 plus 2 into 1. So you'll be getting it as 10. This is for the first stage. Similarly, you can try for the second and the third stage so that I will be getting this triangular fuzzy number. Okay, so the fuzziness is not violated here and I can form the membership function for that also. Yes, sir. So now coming to that, I want to touch this part also, which is also very, very important. I will give only the methods what you are following in the fuzzy graph. I'm not going in depth of it. So the fuzzy graph is same as the crisp graph, but what is the difference here is you'll be giving the membership function for the edges and the vertices. So there are, see this example. This is one friendship network. So I have given some membership function based on that relationship. This person is closely related to this person. So membership function is very strong. So 1. This person is okay related to this person. So the membership function is 0.8. So based on that membership function, you'll be able to frame the fuzzy graph. So now come to this fuzzy graph. The two important concepts you have to remember in the fuzzy graph. One is a graph with known vertices, unknown edges, and a graph with known edges, unknown vertices. And the third one is a combination of these two. Okay, yes. So when you will use this first one, that is known vertices, but unknown edges. Unknown edges means I am going to give the membership for the edges. So here I have given the membership function for the edges. So when you will use this type of fuzzy graph. So for example, if I am having 4 places, I know that 4 different places and these are the connecting road network for the places. So if I know 4 different places I have to travel, that is the vertices. And I know the connecting places, that is a connecting road network I know very well. But because of diversion, because of some road construction, I'll not be able to travel a proper path. So I have to take the diversion, and I have to move. So at that time, I am not sure about my path. So the fuzziness is created. So the edges are fuzzy here, but vertices are crisp. Now coming to the next one. Here the vertices are fuzzy, but edges are crisp. That means I have different places. That is 4 places. The conference is going to be held on 4 places. Same team is going to conduct. And I also know that how to travel from one place to another. So edges are crisp for me. But I don't know where the inaugural session is going to be held. I don't know where the presentation is going to be held. I don't know where the valedictory function is going to be held. I don't know where the talk is going to be held. So I am not sure about that. So I'm giving this vertices as fuzzy. So this one is fuzzy matrix. So fuzzy matrix, usually the matrix means you'll be having some real number inside that matrix. But when you are taking the values in between 0 and 1, then that matrix becomes a fuzzy matrix. So here X and Y are the fuzzy matrix. In a usual addition, we'll be adding the first one with the first one, second one with the second one, like that we'll be doing the addition. But here, if you want to add, you have to find the maximum of the element. For example, in the crisp set, what you will do 0.3 plus 1.0, you'll be doing like that. But here you have to get the maximum of 0.3 and 1.0. So the maximum is 1.0. Similarly, 0.7 and 0.2, which is the maximum 0.7. Like that, we are going to find the addition of the fuzzy matrices. This is an important concept which you have to remember. Next, multiplication of fuzzy matrices. So usual multiplication, how will you get the C11? Usual multiplication means 0.4 multiplied with 1.0 plus 0.8 multiplied with 0.6 and 0.9 with 0.4. That will give you this C11 value. So in here, in the fuzzy matrix method, what you have to do means already I told you for the addition For the addition, you have to find the maximum. So for the multiplication, you have to find the minimum. So while you are doing this calculation, first what you will do, first you will multiply. Then after that only you will add. So here also, first I have to find the minimum of these two, 0.4 and 1.0. It is 0.4. Minimum of this 0.8 and 0.6. That is 0.6. Then minimum of 0.9 and 0.4, which is 0.4. Then after that, you are going to do that addition. That is, you are going to find the maximum of that element, which is nothing but 0.6. So like this, you can get the values for multiplication. So using this, we can solve this medical diagnosis problem. Yes, this is an example I have taken from Meenakshi, and we have also done a medical diagnosis problem using the triangular fuzzy number and the trapezoidal fuzzy number. But this is a simple concept which you will be able to understand clearly. So I have taken this one. It's a medical diagnosis. I have taken 3 symptoms: fever, joint pain, blood count increase, and the 2 diseases, pneumonia and arthritis. Coming to this one, this is the occurrence matrix. So the occurrence matrix, how it is framed means it is based on the symptoms and the diseases we have framed. Yes, so it is given by, that is, we have taken all this from the book, but they have taken that from the medical documentation. Yes, so if they are giving always, this linguistic variables they have given. So always the symptom is related to this disease given means they have given the membership value as 1. So always means it is 1. Very often means they have given it as 0.1. Then seldom means, okay, 0.4. Very seldom, it's 0.2. So like that, based on that linguistic variable, the membership function was given. So now I want to find, this is or not, I want to find the complement of this or not. That is non-occurrence means, what you have to do means 1 minus of that element you have to do. So here 1 minus of 1, 0, 1 minus of 0.2, 0.8, because we are fixing the maximum value as 1. So this must be subtracted from that one and you will be getting this one. Now come to this confirmation matrix. That is also based on the medical documentation. This confirmation matrix is obtained. Yes, so always means we are going to take the membership function as 1. Take it as 0.8, and never means it takes a value 0, and unspecified means we are not sure about it. So we are going to give the specific in between value between 0 and 1, which is nothing but 0.5. Yes, now you're going to come to this patient symptom matrix. Yes, the patient symptom matrix, it is also based on that how much possibility of that symptom to the patients. We have framed, that is, they have framed it, this patient symptom matrix. That is, this patient having little bit symptom of this S1. And when you are coming to this one, this patient has more symptom of this S3. So I am giving the membership function as 1. Okay, yes, now you come to this complement of this, that is non-symptom for the 3 patients. That means what you have to do, you have to subtract from 1. That is 1 minus 0.4, 0.6. Okay, so this is nothing but the complement of this one. Now coming to this occurrence, that is this R1 matrix. How you are calculating this occurrence indication relation? You know what is RS. RS is nothing but a patient symptom matrix. And you know what is R0? R0 is nothing but a symptom disease matrix, this one. You are going to multiply these 2 matrices. Already I told you how to multiply the matrices. Yes, so multiplication and addition will be doing that. So mini-max composition will be using that. Okay, so using that, I got this equation number C. Then you multiply this patient symptom matrix with this confirmation. Confirmation means it's nothing but it is in the form of what? You'll be having this confirmation matrix, symptom disease matrix. So the final answer is in the form of patient disease matrix. You know the multiplication, you can carry on that with your multiplication. Now it's an important result. You find the maximum of this, you take the membership function of this and you find the maximum. If it is greater than 0.5, then that disease is a confirmed disease for that patient. So you take the maximum of these two, it is 8.8. Maximum is 0.9. Here it is 0.7. And here it is 0.5. And here it is 0.9. And here it is 0.7. So here 0.8, it is greater than 0.5. So, and here 0.9 is also greater than 0.5. 0.7 is also greater than 0.5, but here it is equal to, and here, these two are also greater than. So I can say that D1 and D2 are the correct diagnosis for the patient P1 and P3, and D1 is the only possible diagnosis for the patient P2, because this is not greater than 0.5. It is equal to, so I cannot consider. So that only is given here. D1 and D2 are suitable diagnostic for patient P1 and P3, whereas D1 is only acceptable diagnosis for P2. Yes, coming to this one. Here, is check that if it is, if the membership function is greater than 1, that is, if the member is not greater than 1, if the membership function is 1 or closer to 1, I can say that that disease is confirmed disease for the patient. So here in this one, you can see that 0.8, 0.9, this one. So this one is very closer to that one. So I can say that this D2 is the confirmed disease for this patient P1. D2 is a strongly confirmed for the patient P1. Yes, now coming to non-occurrence indication relation. That means what you are going to do means RS is multiplied with, that is patient symptom is multiplied with non-occurrence. So when you are doing that, I am getting this matrix, and non-symptom, that is you have taken the complement of it, isn't it? It is multiplied with this occurrence matrix. I am getting this one. Okay, yes. Next, come to this one. You see that if the membership function of this is 1, or if the membership function of this is 1, then since you are saying it with respect to non-occurrence and non-symptom indication, we can come to the conclusion that that disease is not possible for that particular patient. So here I can say that you see that this one or this one. Here I am getting this as the maximum membership function 1. So I can say that disease D2 is not possible for the patient P2. Disease D2 is not possible for patient P2. So I can come to the conclusion like this. So far as laws of mathematics refer to reality, they are not certain. And so far as they are certain, they do not refer to reality. Albert Einstein says this. So it's a useful quote in our day-to-day life. The next one is the closer one looks at the real world problem, the fuzzier become its solution, says Zade, who is the father of fuzzy set theory. Yes, so if we want to tackle the real world problem, it's not possible for us to make use of the classical set theory. The fuzzy set theory plays a very vital role in day-to-day life. Okay, yes. Thank you. I'm very happy to share this information related to fuzzy set theory to the participants. But I have started from the basics because many students were also there in this team, I think so. So I don't want to go directly to the application side. So I want to focus from the basics. I have started with the basic. And I have not gone in depth of the research also. Okay, I want to create some interest to the participants so that they can take up their research in fuzzy set theory, which is a very, very interesting topic. The computer science staff members, since I am a mathematics staff, I am dealing only with the fuzzy set theory, but the computer science staff can also go for the artificial intelligence, and the mathematics staff can also go for that neural network and all. But we are also planning to go to that particular area. Yes. Thank you, sir.
Thank you, ma'am. Thank you very much, ma'am. So a detailed explanation about the fuzzy sets and the applications. Now a small request to all participants. All participants are requested to fill the feedback form, which will be posted in our chat box. Immediately we are posting the feedback link. So all of you, please fill the feedback link and you can followed by download your e-certificate. The link will not be available for a long time, certificate link. So immediately we are posting the feedback form link. So please, all of you fill the feedback form and followed by you can download e-certificate. Now I request our colleague, Mr. Naveen Kumar, Department of Mathematics, to take over the query session. Over to Naveen.
Yeah, good afternoon, one and all. Thank you, madam, for your beautiful session.
Thank you, sir.
Yeah, beautiful session. And the slides in the session were very thought-provoking and very informative to the participants. And even we had a very good response from the participants that the session was very clear and very informative. And the slides were very, very knowledgeable, and it was very thought-provoking, madam. Whatever you have shown, the difference between that is fuzzy sets and the relation between the fuzzy sets and the transportation problems was very nice. And even you have discussed about the difference between the Cripps graph and the fuzzy graph, how we can apply into the day-to-day life here. It was very nice, ma'am.
Thank you, sir. Thank you.
Yeah. So now shall we move on to this questionnaire session, ma'am? Some of the participants have asked some questions here. I'll try to ask the questions. Now, one participant have asked one question, madam. How can we connect the fuzzy sets with the fixed point iterative methods in research work, madam?
Sir, I think this will be related to that algorithmic concepts, I think so, sir.
Okay, ma'am.
Iterative method means surely it will be going for the iteration process. I think that directly they cannot go. They can apply some, if for example, if I want to make use of this transportation problem, I can apply Tora software so that that iteration method will apply there very well. So you can make use of the Tora software or some other software to get the optimization.
Okay, ma'am. And the second question from the participants is how to apply the fuzzy sets in the operation research and ranking function.
So already I have given in the slide itself, sir.
Yes. Yeah, exactly.
The ranking function is nothing but the fuzziness is converted to crisp. That is the 3-valued number. For example, the triangular fuzzy number is converted to crisp. I have done that for that fuzzy shortest path problem. The similarity degree I have given as an example. Okay, yes, sir? Yes, sir. Yes, so you can convert that. So for this transportation problem also, the 3-valued numbers I have given, and I have proceeded with the first stage, second stage, and third stage, so that the fuzziness must not be violated. But what you can do means that 3 numbers there itself, it can be defuzzified using some similarity degree or some other degree. You can defuzzify and you can bring it in the form of a crisp state and you can proceed. But one problem is if you are moving like this, surely the fuzziness will be violated. That is the main reason we are saying that many researchers are defuzzifying and they are bringing out. We have also done the same in the beginning, but after that what we felt, if we defuzzify means the fuzziness has totally lost. So we want to make, that is we have to make the crisp method. At the same time, the fuzziness must not be violated. So like that they have to move, and many ranking methods are there, sir. Jaeger ranking method and many, that is we have also given many ranking methods like convex ranking method, then area measure. Many ranking methods are available and they can make use of those ranking methods to defuzzify the fuzzy numbers. And you said you asked some other question related to what is it, operation research?
Yeah, definitely, ma'am. And one more question is there. How can we apply these fuzzy sets to image processing? One of the participants is asking.
Yes, sir. And that only I told you that image processing and all comes under computer science side. So they can try it, because here I have given only that concept which is related to mathematics side. So image processing and all, it is fully based on the computer concept. So they can verify.
Okay. And the last question, madam, can we apply these fuzzy sets in the Markov chain analysis, ma'am?
Yes, surely, sir. Surely. In what is that mean? Already I told you that that stochastic process, everything, the probability theory. there are many papers also, you can verify that they have applied this fuzzy set theory to the Markov chain process. And I already told you the main difference between the probability theory and also the fuzzy theory. I told you that random and non-random.
Exactly.
Yes,
Yeah, exactly.
So surely you'll be able to do it with respect to the fuzzy set. You can apply that in the Markov chain process. Surely you'll be able to do.
Okay. So, yeah, because of this time constraint here, so all the questions cannot be discussed in the session. So I request all the participants to share your all queries to the madam's mail ID, which will be provided you in the WhatsApp group after the end of the session. And madam is definitely going to clear all your queries in that session. So hope so. And
surely, sir, we will do that. Okay, I will do that.
Thank you very much, ma'am. Thank you very much. And over to Prashant, sir.
Thank you, Naveen, sir. Thank you, Sujata, ma'am, for giving wonderful time and wonderful explanation about fuzzy sets and the application from the basics to the end of the different examples. So now it's a time to give the vote of thanks. Now I request our colleague, Mr. Naveen Kumar, Department of Mathematics, to propose a vote of thanks.
Yeah. Yes, sir.
Over to Naveen, sir.
Yes, sir. Thank you, sir. On behalf of the Department of Mathematics, on my own behalf, I extend a heartfelt gratitude to Dr. L. Sujata Madam for enhancing us in the area of the fuzzy sets and its applications, and sparing her precious and valuable time for the seminar. In this session, the madam has enlightened us on the different numbers such as trapezoidal fuzzy number, triangular fuzzy number, and their applications in the transportation problems. In addition to this, the madam has focused on the fuzzy one-point method, ranking function, fuzzy graphs, and their applications in the real life, which were very informative and useful for the research scholars in I also thank our college management, Principal Reverend Brother Vincent Reddy and Vice Principal Mrs. Jayanti Reddy for encouraging us and giving a constant support for conducting this webinar. A special thanks to Mr. Vijay Kumar and Mr. Raman, faculty from the Department of Computer Science, for their technical support in the webinar. I also thank our staff, faculty, and the students of LFDC for coordination and cooperation in all aspects. Last but not the least, I would like to thank all the participants from the various institutions and research scholars from the various universities for attending this webinar and making this as a grand success. Thank you. Stay home and stay safe.
Thank you, Naveen, sir. Now, once again, small request to all participants. Please, all of you fill the feedback form, and followed by you can click download the save PDF format for the e-certificates. The link will not be able to available for a long time. Please, you can fill today itself. Thank you. Thank you, one and all. Thank you very much, ma'am, once again.
Thank you, sir. Thank you.
Yeah, thank you very much, ma'am.
Thank you, sir.
We'll end the meeting.
Thank all the participants.
Thank you, ma'am.
Yeah, thank you very much, ma'am.
Website, I will send the link. ఇంకా ఏంటి చేయలే మీటింగ్ ఇంట్లో ఉంచారు ఇంకా పోలే చాలా మంది ఇంకా 42 మంది ఉన్నారు నేను హోస్ట్ చేయాలి కదా ఎండ్
హలో మాస్టర్
నేను ఎండ్ చేసుకొని రమ్మంటారా లీవ్ అంటారా
సప్న మేడం నువ్వు ఎండ్ చేసేసి ప్రశాంత్ సార్
అని
మేడం